Hey everybody, in this video, we're going to talk about derivatives of inverse trig functions. Specifically, the big question is how do we find the derivatives of sine inverse x, cosine inverse x, and tangent inverse x? Let's start with y equals sine inverse of x. Our goal is to find the derivative of this function. Well, if y equals sine inverse of x, that means x equals sine y. And now we can take d dx of both sides. d dx of x is just 1. d dx of sine y is cosine y times dy dx. Now we can solve for dy dx, which is 1 over cosine y. But now what we need to do is figure out how to get cosine y in terms of x. So let's draw a right triangle. Remember, we started with x equals sine y. That means y is the angle, and the opposite side is x, and the hypotenuse is 1. Let's call the missing side a. Now we can use the Pythagorean theorem to solve for a. After doing this, we get a equals the square root of 1 minus x squared. Now we can find cosine y, which is the adjacent side over the hypotenuse. And that would give us the square root of 1 minus x squared. So dy dx equals 1 over cosine y, which is 1 over the square root of 1 minus x squared. And now we can summarize. The derivative of sine inverse x equals 1 over the square root of 1 minus x squared. Go ahead and commit this to memory. Now let's find the derivative of y equals cosine inverse x. If y equals cosine inverse x, that means x equals cosine y. So we can take d dx of both sides, and that gives us 1 equals negative sine y times dy dx. Then we can solve for dy dx, and we get negative 1 over sine y. Now we need to get sine y in terms of x. So let's go ahead and draw a right triangle. And remember, we started with x equals cosine y. Y is the angle, and cosine y is x over 1, and that corresponds to the adjacent side over the hypotenuse. Now we need to solve for the missing side of the triangle using the Pythagorean theorem. Just like the last example, we get the square root of 1 minus x squared for the missing side. Now we can find sine of y, which is the opposite side divided by the hypotenuse. And that's the square root of 1 minus x squared over 1. That means dy dx, which is negative 1 over sine y, equals negative 1 over the square root of 1 minus x squared. And so we can summarize. The derivative of cosine inverse x equals negative 1 over the square root of 1 minus x squared. All right, let's now find the derivative of y equals tan inverse x. If y equals tan inverse x, that means x equals tan y. So we can take the derivative of both sides. d dx of x equals d dx of tan y. And that gives us 1 equals secant squared y times dy dx. Then we can solve and we get dy dx equals 1 over secant squared y, which is equivalent to cosine squared y. So now we just need to get cosine squared y in terms of x. So let's make a right triangle. If x equals tan y, that means y is the angle. And remember that tan y gives us the opposite side over the adjacent side, which would be x over 1. Now we just need to use the Pythagorean theorem to solve for the hypotenuse of this triangle. When we do this, we get the square root of 1 plus x squared. And that means cosine y equals 1 over the square root of 1 plus x squared. And that means cosine squared y equals 1 over 1 plus x squared. And that means dy dx equals 1 over 1 plus x squared. So we can summarize. The derivative of tan inverse x equals 1 over 1 plus x squared. And here we have the three derivatives that we were trying to find. Note that the derivative of cosine inverse x is almost the same as the derivative of sine inverse x. It just has a negative sign in front. Go ahead and commit these to memory. As we end here, I also just want to remind you that you may sometimes see different notation for inverse trig functions. Sine inverse x might be written as arcsine x. Cosine inverse x might be written as arccosine x. And tan inverse x might be written as arctan x. In the next video, we'll look at some example problems involving inverse trig derivatives. In the meantime, make sure that you understand the derivations shown in this video. And that's how you rock calculus!